All right, everyone. We're going to get started in about 1 minute. So I always like to begin by recapping. And we are on number 6 of 6. And in this session, it's about quality control. So we, again, ramped up. We started with component identification. We went through elements of the wire assembly. We moved our way into the build, repair, and replacement of some of those components. And then we started tapering ourselves out to now we're talking about end product, right? And the end product could be the repair in the field, or it could be a build here at Aeromotive. Either way, quality control is everything. Aeromotive is an ISO 9001:2015 certified company, and we take that qualification very seriously. It is a part of our culture, and throughout the culture in our corporation, quality has always been a focus of ours. Whether it's internal customers or external, we're working to maintain that quality control. So we moved a bunch of equipment into this area today because I didn't want to be bouncing around from different sections in the plant. So I decided to move what I could into the scene so you can get an idea of what goes into some of the testing requirements. So I want to go start working my way through some of the equipment to give you an idea of what some of it does and its capability. But then I also will start working our way into what can be done in the field. And that's kind of significant, right? Because a lot of this stuff we want to keep on the vehicle. We don't want it to come out over to us. But I'll take it, but we rather just keep it on the automobile. So we're going to start with the power supply. Sometimes it's very advantageous for us to put power onto a system to see if it has the capabilities and the properties that it's needed to power up, say, maybe a motor or a servo or even a circuit board. We've used this in a couple of different applications on hybrid. It's an AC power supply, and there is a portion of the hybrid that is AC before it gets converted, and we need to be able to test that AC function as well. As we go from the power supply, we're going to move our way over to a high pot tester. So you might ask yourself, what is a high pot tester? Good question. It tests high potential or more essentially dielectric properties. Again, what do I mean by that? Well, we're going to have Nick, who is our lead technician, come over and kind of give us a demo on that. But first, I want to give you a little bit more explanation. The high pot tester is an electrical test, and you use it for testing a few different properties on a wire assembly. Basically, we're testing the insulation properties first, right? We want to check for items such as creep and items such as clearance. Now, what do I mean by those two? Well, we're passing a high voltage surge through the wire assembly, we want to see if there's any weaknesses in the insulation. So think again of electricity as water. And as water begins to flow downstream, if it finds an avenue where it could branch off or merge onto another section, it will take that path of least resistance. So same thing with the insulation. If it's nicked, if it's scraped, if it's shallowed out, that potential discharge will be picked up through the high pot tester. A really, really good way of testing new product coming off of production builds, prototyping, and of course, first articles that need to be built. So it also checks, that would be creep, right? Another good example of creep, I'm going to pull up the circuit board for you real quick. Creep and clearance. So creep could be the amount of discharge or between the two terminal or solder points along the surface of the board. So creep is a surface requirement or a surface specification. So it could easily creep from this side over to that side if it has a pathway, right? Maybe the board is too thin. Maybe there's some crossing over of pathways. The outside of creep, we have clearance, and clearance is the distance now between two terminals. So clearance would be between these objects or these terminals. So it can check as we're doing a high pot. It's going to check for creep and it's going to check for clearance. The clearance part also comes into play when we're testing something as simple as this. And clearance can definitely be an issue if the terminals are spaced too closely together and we're passing a lot of voltage or current through this. You have the potential for arcing. So when you're designing, when you're testing, those two items are really essential to keep in mind. I'm going to have Nick come over now and give you an idea of what the high pot test looks like. And I also want to kind of give you an idea too what's happening here. We're looking at two different types of testing, right? Mechanical and electric. Right now we're going to focus on the electric side, and I'm going to have Nick come in and give us a rundown on the high pot. Hey Nick, how you doing?
Hey Carl, how you doing? Everybody else?
Welcome back. Welcome
Yes,
back.
yes.
We'll try not to get the back of your head, okay?
Okay. Yeah, I was gonna
No, you're fine. I'm teasing. I'm teasing. All right, Nick, why don't you give us an idea of what we're going to do here today on the high pot?
Sure. So we're just gonna go through the simple testing of a harness. Basics. Let's start with the basics on this one. Uh, like you said, quality control is very important. Almost just as important as keeping a record of those quality controls. Before we can even test this harness, we have to make sure that a memory card is installed so we can save all of the testing that we're doing.
Mm-hmm.
This will not perform a test if it does not have a memory card in it.
Oh, very good. So we always have a profile on every object we run through the high pot tester.
Correct. Absolutely.
Okay, great. Because our customers want to know that as well, right? They want a record of our quality control process. There's PPAP programs, right? That have a control plan involved in them, and that control plan requires certain elements to be checked, and this is one of them.
Correct.
Okay.
So here we have a known good sample. It's tagged as accepted. What we'll do is plug in each end right here.
Mm-hmm.
Plug in each mate. And then we already have a profile made up for this specific harness.
Okay, so you had to program it first.
Correct.
So you built yourself a first article
Mm-hmm.
or a prototype sample of some type.
Exactly.
And then you got that approved though too, right? You had to send it to the customer, I suppose, so they can also verify it.
Exactly.
So then when we get that back, we're saying, hey, now we have two people that just checked this assembly out. Now we can run tests on that on a regular
Yep,
basis.
exactly. That would prove that golden sample to be good.
Prove the golden sample. Yeah. Okay.
So the harness is plugged in. We're just gonna hit this green button on the run. Right there.
Wow, that was pretty fast.
Yeah, that's
That was
really
pretty fast. And how many circuits do you think we could test with this particular high pot?
With this particular high pot, the back here has room for at least, I think, 3 more connectors, which I think we can get up to about, I don't know, 250 circuits minimum.
Mm-hmm. Okay, great, great. So a couple of high pot testers in series can do a wire assembly with say over 1,000 circuits.
Easily.
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 Yeah, and that's the idea, right? To mate our high pot to the wire assembly.
Absolutely.
So we just ran a high pot test, which has given us an idea of what the installation looks like. It also told us that it's properly wired.
Correct. That's what, when we make the profile and we prove our golden sample, we can make a learning program to learn this circuit as it's good. I have 2 defects right here. We
Okay.
can plug in and we can see that the high pot will pick that up.
Sure, sure. So the high pot's also checking for shorts, right? And opens. An open can also be a good purpose or use for the high pot for opens is if you have something that's corroded, right? Say we receive a wire assembly and it had water intrusion, and now we're concerned about corrosion affecting the terminal and contacts. The high pot can pick that up because the wire will start to degrade, which means it's not going to carry as much current as voltage, and the high pot will recognize that.
For this one, I swapped the wires, the black and white wires, into the opposite pin positions. So this is going to demonstrate a short that the high pot can pick up. I'm going to go to test this. Right here. And yeah, right there we'll say short. So this is showing that the program in here is recognizing that there is a fault in this circuit.
Yes.
It won't allow you to go past this.
Okay.
You need to unplug it and it will not save that test
Okay.
for it being wrong.
All right, very good. So it did recognize the fact that it was miswired,
Correct.
which is the result of the open that you built into it,
Mhm.
right? So the open could be, again, the wire could be open, the terminal could be poorly crimped. There could be even some strands. Maybe we had a bad strand not properly crimped to the terminal. So good examples of the high pot.
Mhm.
We're going to move a little bit now, Nick, and I'm going to have to ask you to swing around
Sure.
because and we definitely need Katie to come over for this. So we're going to be moving to a mechanical test now, and we talked a little bit about mechanical tests. One was the crimp height, and we have a terminal here that we have already broken down and evaluated for the proper crimp height, and it is part of this cooling fan connector. We chose this for a couple reasons. One, it's pretty big, and it has a nice pull strength to it and a pretty good crimp. So I don't know if this is going to pass or fail yet. We're going to try it. We had it crimped just before we went live. So we'll see whether our tooling is up to spec or not. And also the spec. What do we use to determine whether it has the correct pull strength or not? Well, the OEM specification. That's everything, right? We want to go back to the OEM and they're going to tell us, and that's very small font. I know you can't see it, but it is highlighted here. The pull strength required when you have the proper crimp for this particular terminal. What if we don't have this? Well, there's guidelines or standards that we can follow that'll tell us that for a particular wire gauge size, it should have this type of pull strength, but nothing beats the OEM specification. So Nick, I'm going to let you take over, okay?
Sure. Move that connector. If you want, I can actually pull this exact screen up onto the computer so it'll be a little bit bigger for you guys. This right here.
Okay.
I'll be putting this terminal right here into this notch,
Mhm.
making sure it's nice and tight, and then I'll hit this green button, and then that same screen will show up there. Oh yeah, great crimp. It's all the way up to 109.
Okay. So you said great crimp, and boy,
Correct.
that really did some destructive testing there, didn't it? Wow. Okay. And you said great crimp because the specification gave you a range.
Correct.
All right, terrific. And then you said now all that data just transferred over to the program again, so we're saving it and storing it again.
Yeah, correct. We have a USB plugged into this computer with
Hmm.
this program loaded on there. Right here, if you wanted to, there's an export to Excel. And
Hmm.
if I hit that button, it would make an Excel file of exactly what was tested right here that we can send out or save for internal uses.
Right, that's fantastic. So we do a lot of sample testing, and it's a requirement, right? Because of our quality control standards, we have to PPAP, we have to verify that our processes, and more importantly, we're really checking the tooling,
Correct.
right? Make sure our tooling is up to par. All right, so mechanical testing, and then there's a visual that we can do as well. But again, the magnifying glass might help in some cases, but when we're doing mechanical testing, we might want to check it beforehand to see how the crimp looked, but still pretty good stuff. All right, we're going to keep moving across the table, and some of the things that are worth noting is the necessity for tagging the articles, right? I mean, I don't want to lose control of this. And we need to make sure that it gets properly tagged. It's then accepted, and then if it's a reject, the process really starts moving into high gear then. Why do we have a reject? And it gets pretty in depth. We really have to go all the way back through our processes and basically start all over again just to make sure that we don't have a failure 3, 4 steps back in our control plan. So documentation is very important. I'm going to continue moving over to this side now, and I wanted to point out the multimeter, or in this case, our volt ohm meter. Obviously, this is a benchtop style. It has a lot more capability, but for you folks in the field, this is an ideal tool here. And I'm going to give you an example of what kind of uses this could have. So I'm going to give myself the tone and a resistance check. I'm checking basically for continuity here. And one of the things that I want to check, and I'm going to kind of make sure I'm standing still, there we go, is whether I have a good wire or not. So I'm going to use some jumper leads that I made, and I'm going to show these to you in a minute. And I'm going to insert my jumper leads. And essentially, if I have a good wire, right, whether I'm going from terminal to terminal or across the whole length of an automobile, I should have tone, which means there's no resistance on this circuit or wire. Good position to be in. This will also help you determine on the vehicle whether you have something wired correctly or not. And the OEM wiring diagrams are the key. You have to make sure you have the proper documentation going into the repair. One thing I wanted to show you folks in the field, and it's worth taking the time. Build yourself some wire leads. Let me give you an example. Let's say you're probing this connector and you need to get into this terminal. You don't want to force your way in there with a round. It's not going to fit. You're just going to elongate the terminal, right? Or maybe a blade that's too wide. So take the time and find yourself a terminal that fits that application. Now you don't have to worry about elongating the terminal. I would do this. I would take your banana plugs like this, or this, and cut them off your ohm meter and put them onto a round circular contact or open barrel terminal. Then you could come back and you can build a whole bunch of mating ends. So I'll just put that in place real quick. I'll crimp that down for you. Now I have one end that can fit into my meter. I'll bring that over for you. Right? So now they're interchangeable. Now I can swap leads over, and what I'll do is I'll come back and I'll put the proper sized terminal for the end that I want to test. And again, I'm not doing a very good job of crimping, folks. I just wanted to kind of walk you through the quick application for a jumper lead. And now I can go into my connector. That took a whopping 2 minutes. Right? 2 minutes, and look at all the headaches you would have avoided by trying to probe that without the correct size terminal. If necessary, you can go through the backside and try and stab it from the backside. But again, you're kind of running into some issues here as well. You can deform the terminal. You might pierce the insulation. So we want to kind of stay away from that. So your multimeter is really your go-to weapon on the automobile. Okay. Again, very inexpensive. All you really need to do is check for tone, and it does do other things such as voltage. I want to bring Nick back into the picture because I want to talk a little bit, and I mentioned this earlier, about future technologies. And one of them is called the FACRA. FACRA is a German automotive standard. And one of the standards they built is this style of connector. And you've seen these before. I know you have, because they're all over the automobile. I labeled some of them for you. Satellite, AM, FM, right? Your Sirius radio, right there. Television or monitors, seatbacks, cell phone, and power leads. GPS. Each one of these color codes references that system. So I can go into this system and I can know whether I'm working on the cell phone side, the GPS side, perhaps maybe the satellite AM FM radio side, but in any case, I can get in here and get an idea where I'm at, where I'm going. What makes these difficult to work with in the field, it's the sheer size of the terminal. And I'm going to definitely have to have Nick demonstrate that for me. The only thing that I could recommend at this point is that if you have something that is damaged, keep your focus to the housing and the housing only. This can be swapped off and on, off and on. Now, there's quite a few of these in the marketplace, like the connectors on an automobile, the different configurations, the guides, uh, tons. Tried to standardize some of it. So basically, you want to look at this as two types of connector styles: the FACRA side, which is European, and the U.S. car side, which is obviously U.S. standard. So think about that going into it, and it'll give you an idea of what family or what type of connector line you're going to be approaching. There are some elements I wanted to point out about this. One, you have the housing, you have a barrel, and I know you're not going to be able to see this, but there's a contact. That is some tiny stuff, folks. Uh, Trying to get that contact onto this coaxial center conductor is a nightmare in the field. I'm going to have Nick give you an idea of what we need to do to make sure we have the quality that goes into inserting the terminal in the field. Now, Katie, you might have to come over on my side and show the screen here because Nick is at 300 times magnification here. And as you can see here, you have the braided shielding, right? You have your insulator and your center conductor. Now, 300 times. Now, Katie, if you could take a look at what we're dealing with down on the magnification table, you can see the issue here. Now, Nick is going to need to go into that with a pair of tweezers. All right. Now, one nice, nice strip length. That just looks really, really good. Nice strip length. It's butted up firmly against the insulator. The crimp is the next thing that's going to be difficult. It's not even possible here with any hand tools. This is going to have to come back to more of a machine application to get the correct crimp specifications for this center conductor. But again, look at the size we're dealing with here. This is tiny, tiny stuff, right? And we'll give you an idea of what can be done in the field. But primarily, folks, unfortunately, this cabling is going to need to be sent in. You're going to need to send it into us, give us the opportunity to basically build you a new cable. If we can do something as simple as, hey, it just got stripped out of the housing, great. We'll go back in there. We'll see if there's enough strip length left so that we can re-terminate it and return it back to the customer. Okay. Again, many different sizes of this, many different coaxial center conductor diameters, which is something to consider too. Just like there's gauge of wire, there's gauge of center conductor. And we found that's probably the biggest hassle. Yeah, I got Nick over here nodding yes. So obviously he's dealt with it many, many times over and over again. And then as we go to our final station over here, dealing with the FACRA, this will give you an idea. And I'm going to say US car as well. There is, as I mentioned, there's not a field repair kit for it. There really isn't. This field repair kit can probably get you to crimp something like this. A barrel type, open barrel type connector for the US car systems or FACRA systems. This set can get you that. But the problem you're still going to experience is, what do we do about the center conductor, right? What do we do with this tiny, tiny terminal here that's going to, in this case, come up through the center of your contact? Terminology's changed a little bit as well. We now have jacks and plugs. This is a plug. It's basically the male side. And this is the jack, which is basically the female side. Again, all keyed, right? Keying is everything again. And these should mate. Oh, look at that. Even with the correct system identified, we still have a size issue here. So again, like many of the other connectors that we've dealt with in the series, always good to have a photo or an image of what you're dealing with so we can get an idea of what type of replacement items you're going to need. I'll let Katie get back to her station, and then we'll start closing things up for you. Thank you very much again, everybody, for tuning in. We're going to be rerunning these series. So if you missed us the first time, you're going to be able to catch us the second time. And I'm sure Katie will be in touch with you folks to let you know when that opportunity comes available. In the meantime, if you have any questions, think about our virtual support line. And our virtual support line could, right now, the only platform is FaceTime. So you'd probably need some type of an iPhone device to be able to contact us. But it's Aeromotive Virtual Support. You should be able to find us that way. Give us a ring, and we'll see what we can do to help you out. Everybody, have a safe day.